Hello everyone, welcome to another video tutorial of the FEMM software. In this video, we are going to complete the MATLAB code and run the simulation via MATLAB. So in the previous video, we created the geometry, we assigned labels. Now we should set materials, boundary conditions, and so on. So let's run the code. Right, we have created this geometry, and now we should add materials and then assign materials to these labels. So from here, properties, material library, as you can see, we can add air, add material, we can drag and drop it here. Also, we can add pure iron, and we can add SWG, right? Number, any gauge, and also we can add pure iron. So how we can do this by code? Let's check the document, the help. We have a function for adding the materials. So this is the function name. Actually, let me search. I get material. Yes, object properties, get material. So using this command, we can add the available material that already is in the library. So copy and I write a comment here, add materials. I want to add pure iron. The name should be exactly this name. Okay, so you can copy and paste it here, materials that you are going to use. So I want to add air also, air, and want to add this gauge just for current, add. So if I close this design and run the code again, and let's check the library. So we have added pure iron, but we have an error here. Get material. This material is not available. I think I used a wrong name, right? Yes, I said we should use the exact name, air. And now let's close and run again. So properties, material, pure iron, air, and this wire gauge. So we have added materials, and also we should define the winding. We should define the circuit, right? As you know, from here, circuits, we can define a new circuit. So how we can define circuit by code? This is the function name, add point properties, add circuit prop, right? Magnetic input, add circuit prop. So we have three inputs here. Circuit name, I, that is the value of current, and circuit type. The circuit type, if the circuit type is 0, this is in parallel, and 1 for series connected. So I want to use this function, circuit prop, and I write here a comment, define circuit. The circuit name, I write coil 1, and the value of current 1 amps, and the type series. So let's run and test the code. So here is the defined circuits, coil 1. Modify, the value of current is 1, series, and this is the name. Anyway, so how we can set properties of these labels? First of all, we should select label and then assign the corresponding properties. So we have this function here. The function name is select label, I think. So let's check. Yes, this is set block properties. Before that, we should select label, this function. Magnetic input, select label. So I have installed a new version of MATLAB, and that is smart. If you write MI, right, you can see the function name in the recommendations. So I write select L label. We have two inputs, the X and Y coordinate of the label. So here are our labels. Yes. I think even we can cut this, and after definition of circuit, immediately we can set the properties. We can add block, we can select it, and then we can set the properties. Set block prop. So here we have these properties, block type is material, in circuit or no, number of turns, and so on. So here are inputs. So I write here MI set block properties. This is pure iron. This is in the middle of the yolk. Pure iron. The next input is auto mesh. Yes, mesh size determined by the software. In circuit, no. Magnetization direction, group, turns, 0. So let's try the code, run, and check. So we have defined properties of this label, pure iron, and you can see the rest of the settings. So the next label that we add is this one, width of window plus width of view plus gap. This is also the same. We should select this label and let's run the code. Run. So this is pure iron, none, and yes, also we should set the exact coordinate. I forgot this. Okay. So what is the next one? Select coordinate, paste, width of window divided by 2 plus width of yolk, and this. This is air. Run. Air. Okay, I think we should deselect, after selection of this object, we should deselect. So from here, set segment properties and set group. Even we can change the mode, I think. When we select the labels, the software hold them, right? Hold also the previous selected labels. So how we can restart label selection? Let's try. Here we add this block, we set, so we can follow the code. I place the breakpoint, we add pure iron, place a breakpoint, run. We added a new label. This is also pure iron. And now, we have two selected objects. Okay, so stop and close. And then we should use this function, clear selected mi. So after each selection. So we add label, we set properties, then we clear selected. Now let's try the code. As you can see here, we have pure iron, air, pure iron. So we can select these two labels properties using the same method. Copy, paste, copy, paste, and set properties here, properties here. This is the material in circuit, yes, coil 1 and coil 1. Number of turns, right here, 100. Number of turns. So if we run the code, as you can see here, we have selected these properties and yes. So this one, number of turns, coil 1, and also we should copy and paste this here. Save. Anyway, so how we can set boundary conditions? First of all, we should select edge and define boundary condition and assign. So from here, we can set the boundary condition. These are mesh commands. Zoom, view object properties, delete material. So we should have the boundary conditions also. Add boundary prop, right? So I write here, add boundary condition, mi, add boundary prop. The name, let's make this comment, run. Properties, boundary, add boundary. This is the name. This is the boundary type. So, right, you can see boundary type, prescribed A, periodic, anti-periodic, and so on. So I want to define zero vector potential boundary conditions. So here, I write this name, 0A, zero vector potential, 0, 0, 0, 0, 0, 0. So you can see the document also here, right? This is the prop name, A0, A1, and so on. So we have this important parameter, the boundary format. So you can see the type of boundary conditions here, right? To 5 to set all parameters equal to 0, right? Anti-periodic, periodic, and this is prescribed A. Okay, so if I run the MATLAB code, run properties, boundary, we have defined 0A. So modify, this is prescribed A, and all values are equal to 0. So now how we can assign boundary condition? We should assign boundary condition to these 4 edges, 0 vector potential boundary conditions. So like before, we should select segments. Here are our actually enclosure. Here are points, right? So even I can cut this and assign it here, P. So I can write, for I equal to 1 to 5, and we have 4 points. We draw a closed polygon, and we can extend the matrix P. You know, this is P. If I write P equal to P and P1, I can concatenate the first element to the last one. Okay, so I use this command here. So we have 5 elements, and then I write P middle. The middle point is P, I, and this plus I plus 1. So we can actually find out the x and y coordinate of the middle point of each segment. Then mi select segment P mid 1, middle point P mid 2. Let's check. Close this and run the code. As you can see here, we have selected all boundary segments of outer enclosure by code. So finally, we should assign index. Yes, I should write here 4. Excuse me. Finally, we should assign the property. So we should have a function like this: set edge prop or set segment prop, right? Mi set arc segment prop, block prop, or segment prop. So these are segment properties. We can check the software. So if I press space, select this segment, these are properties. So the first one is the boundary condition. Okay. So the property name, I write here 0A, and let's review the set segment prop, this one, mi set segment prop, boundary, element size, auto mesh, hide, group, right? So I set the rest 0, 0, 0, 0. And finally, mi clear selected. Clear the same function that we have here. Yes, save. So we can run and test. Close, run. Let's check 0a. This is the boundary condition. And now we are ready to run the simulation. Yes, but before that, we should save the design. I want to save the design in the current MATLAB folder. So you can see the save function, and also we have this important function, problem definition, to set the units and so on. The unit now is inch. Problem is inch, but also we can set the properties via the code using this function. Probdef. Let's set mi probdef. What is the frequency? We are doing magneto-static. What is the unit? The unit is millimeters. Copy, paste, and I want to use millimeters. Later, when we do electric motor design, we will use the same unit. And the next input is the type, precision. So the type is planar. Problem definitions. The type is planar, planar, plan. Here also you can see in the document we can copy, paste the exact syntax. And the next input is the precision, solver precision. The next one is depth of the problem. Depth of the problem, for example, for radial flux motors is the stack length. So I write here 1. Depth of the problem. Then we have mean angle 30. And AC solver. You can use the same name. When we want to do simulations in harmonic space. So copy and let's use the same name. Point approx. Anyway, let's try the code. Run. Problem definition millimeters 50 and so on. So how we can save the design? Using this function, save as, right? Or we have also this function here, save bitmap. Even we can save the current view access. So I want to save it in this current folder. But what is the path of the current folder in MATLAB? If in the command window you write current directory, This is the directory of the current folder. And if I write cd plus, I can concatenate two strings, my file, can write my file, right? This is the file name that I want to save. So from here, magnetic input, save as, also we have save dxf and other options. The path, this is the function, save as function. Let's find out. Editing command, mesh command, save as. We should write the file name, right? File name. And if you use a path, you must use two backslashes. Okay, how? You know, we can use this function str replace and replace current directory, replace every backslash with double, right? So we can use this function here, current directory plus, I write here file or design1. Design1. Let's try this code. Run. We got error. What is the error? And this is the directory name. Design1.fem. Let's try FEMM. Close. Run. Still we have error. I think maybe this is a char. You know, in MATLAB we have char variables and string variables. For example, this is an string. If I write here class A, but if I write x equal to Ali, class x, this is char. So if I convert this string to char variable, maybe can try. Yes, now as you can see here, we have saved the design1.fem. So why design1? For example, you want to change the value of air gap, do magneto-static simulations, and export results, right? So if we did everything by code, we should be able to run the simulation, even we saved. So generate mesh and solve. No, so was not found. Save, generate mesh, and run simulation. The software cannot find the mesh. What is the reason? We assigned boundary condition, we assigned properties, label. These are properties. In group pure iron, problem definition is correct, but we cannot run the simulation. So let's check out. I comment this line, run, generate mesh, solve. So as you can see here, we have these documents generated by software, but still we cannot run the simulation. So we have assigned boundary conditions and we have assigned materials. Let's check this segment. Zero vector potential, boundary condition, 0, and even we assigned correct materials. This is air, pure iron, and we have 2 coil arms. Block type is not defined. We defined the block type, but I think the name is wrong. So now let's test. We assigned the block type. So let's test again. Run, label. This is the label name, block type, coil 1, pure iron, and air. In circuit, no. So rate the duration anyway. So let me test. Okay, let's generate again. I think maybe we should save. We have 2 options here, save and save as. So let's find out. MI save bitmap, close, save DXF, and so on. So here are boundary conditions, problem, and properties, boundary, segment, 0A. So what if I save this design, save, generate, and run? No. Save, close, highlight this code, run, and assign boundary conditions. Yes. Save the design. I save it on computer. Desktop. Untitled. Save. Yes. Generate mesh. Run. Yes. So we are able to run the simulation when we save the design directly, right? So what is the reason? Here just we set the boundary condition and we set the result. So let's generate the model once more. Segment and save as. Want to save it desktop, design 1 .fem. Yes. Generate, run. Yes. No, I should write here .fem, run, generate mesh, solve. Yes, I used the wrong name. So now it's correct. And we should be able to set the simulation, boundary conditions, and solving the problem. So why we don't have the correct distribution inside the iron? We have pure iron here. Yes. And pure iron here in circuit series. Yes. And Yes. So, but in the previous model, when we created the model, save, run, line, yes. I think also we have an error when we set the problem type, you know. So let's check the problem definition. These errors are good because in future you might get these errors. So you will be able to resolve these errors. So what was the function name? Problem definition. Here is our problem definition. Problem, the problem type, and the unit. So the unit, problem type, frequency, the precision, depth, mean angle. This is the mean angle, and this is the solution type. A smart mesh on. So let's try again. What is the error? Millimeters. So lower letter, tag name. So this is correct. Generate mesh, run, check the results. So, when we set this problem, this is planar, millimeter, frequency, depth, a smart mesh. Now, anyway, so I highlight this and we will resolve this error in the next video. So I think it's good for this video. So you can create the model, assign properties, define circuit, and run the simulation even via MATLAB. If you run this command, mi, we can run the simulation directly using analyze command. Analyze. Okay. So you can see the function, magnetic input, analyze. Right? This is the flag. So I write here 0 and let's try. Run the code. Yes, we generate the model, we run the simulation. Even we can show the results. Load solution. Okay. mi load solution. So if we run the code, we generate model, simulate, and load solution. Now it's straightforward. We can change the value of air gap. We can run the simulations, analyze, and calculate properties that we want, like flux linkage and so on, that we will do it in the next video. So thanks for watching.